Hello and welcome to this talk on build cloud infrastructure using Python. My name is Sohan Maheshwar. I'm a dev advocate with AWS and I'm here to talk to you about this very cool new cloud concept called infrastructure as code. So today, like I said, we will be talking about infrastructure as code. We will talk a little bit about AWS CDK. We will talk about how it works and also on getting started. Now, this talk is aimed at a beginner to intermediate level. So if you don't know too much about cloud or cloud infrastructure, or even Python for that matter, this is a good talk for you. Right, so let's get started. Now, a couple of years ago, or maybe it was a few years ago, what is time even right now, our CTO, that is AWS's CTO, Dr. Werner Vogels, said this at our annual conference at reInvent. And he said, so what does the future look like? All the code you ever write is business logic. Now, for those of y'all in the crowd who do coding on a regular basis, you will know that you end up writing a lot of code to actually scaffold the business logic that your company typically needs. But we are slowly moving past that. If you really look at how coding has evolved, especially when you're building applications, we've gone from building huge monoliths, which is this massive application with so many interdependencies, to a list of microservices. And this is how modern applications look like. They have a lot of bits. So you have your database, which is talking to your data lake, which is talking to your serverless app, which is talking to your data warehouse, queuing service, notification service, and all of that. This is how typically a modern application looks. Now, to create all of this, how do you actually do it? How do you actually create a serverless function or a database or a queuing system? And that's where really infrastructure as code comes in. How do you create these pieces of cloud infrastructure using code? The lowest level of actually doing this is to create this infrastructure by hand. This is typically you have like one awesome person in your team, and this person's doing all of this using like a console. So if they're using AWS, maybe the AWS console, and they're like coding and they're doing all of this by hand, and they're creating your organization's infrastructure. Now, this is not recommended at all, because this is very manual, it's time consuming, it's hard to audit. I mean, even the best of employees can make a mistake once in a while, so it can be error prone. And most importantly, it's not reproducible. This is literally the equivalent of saying, hey, ask Alice, she knows what to do. Because one person's doing all of this and then they have to teach another person, or there's a wiki, but it's not reproducible and it's not programmable. A layer above that is something that organizations have been using for a fair amount of time. And this, in a way, is infrastructure as code, but it is imperative infrastructure as code. So you have your employees who create, say, some things like a deploy script, a typical shell script, which has things like, if your resource is equal to this, do this, else if. So there's a lot of boilerplate code for this, but it is, in a way, automating how you create cloud infrastructure. With imperative infrastructure as code, what if something fails and we need to retry it? Now, this is a straight up script. So if something fails and something happens, that's it. You can't do much. Also, what if two people try to run the same script at once? And the larger the organization, the more the chances of this actually happening. So this could lead to things like race conditions, where two things are trying to create cloud infrastructure at the same time. And of course, could lead to a lot of errors and could lead to a lot of downtime, and we don't want that. So the level above this was something called declarative infrastructure as code. And a lot of organizations even now use this, and of course, I highly recommend it. So what happens is you write infrastructure as code in something like a TXT file, and you use services like AWS CloudFormation or HashiCorp's Terraform. Now, this speaks to something like the AWS SDK, which then goes ahead and creates your organization's infrastructure. Let me give you a real world example. So suppose you're programming a robot to get you coffee at 9 a.m. on a Monday morning. Now, this is very declarative. So you have to declare each and every step that the robot has to do. So you have to say, robot, walk 10 steps down the hallway, take the first left, find the coffee machine, add milk to it. I like milk in my coffee, add coffee powder, put a cup on the mug and bring it back, So you're actually defining each and every step. You're being declarative about every step that robot has to do. That is what declarative infrastructure as code is. So typically that TXT file contains YAML or JSON code where you define literally every single thing about your infrastructure. So as an example, if you're creating an virtual private cloud or a VPC, so you say, I want to create a VPC, these are my subnets, these are my NAT gateways, these are my CIDR blocks, these are my availability zones. Don't worry if you don't know what any of that stuff is, I barely do. But essentially you're defining every single thing in that virtual private cloud. A lot of organizations use this because, like I said, it's very different from that level 0. So this is reproducible. It's not as prone to error. It's not time consuming. So you can actually, and people can work on it at the same time. So this is infrastructure as code, essentially at its very logic. So you're coding in YAML or JSON, two ways to represent data. And you can maybe store this file on, say, an S3 bucket. And you create infrastructure stacks using a service like AWS CloudFormation. So you're saying, okay, create a virtual private cloud, create a database, create a Lambda function, and all of this is being created using CloudFormation, and your company's infrastructure is ready. Now, this is all well and good, but a couple of years earlier, AWS introduced something which turned it a little bit and called it infrastructure is code, where you could do all of this using your favorite programming language, which in this case, I assume is actually Python. So today we're going to tell you how you can build cloud infrastructure using Python. And honestly, I like giving this talk because I know a lot of people who code Node.js, Python, etc., but they're not sure that you can actually write code to create cloud infrastructure. And it usually blows their mind. They're like, oh man, that's so cool. Because honestly, I find writing cloud infrastructure using YAML or JSON fairly tedious. It's a lot of lines of code. But I know Python or JavaScript programming and I can get started straight away. So that onboarding to creating cloud infrastructure is so much easier. There is no context switch. You can use the same ID that you're using. You can use the same CI/CD pipelines that your company uses. And of course, it's completely customizable, it's shareable, and you can use constructs from programming like for loops and if-else statements and conditions to actually build cloud infrastructure. How cool is that? So let's take a look at CDK and infrastructure is code. So how it works in CDK is you would write a simple program. So let's call it app.py. And that app.py interacts with Cloud Development Kit, which then creates your infrastructure stacks using CloudFormation, providing that another layer of abstraction from writing verbose CloudFormation code. Now you might think, hey, is only Python supported? I'm a person who writes in multiple languages. No. CDK is supported in TypeScript, in Java, in C#, in what else? JavaScript, Python, of course, and Golang support, which is coming soon, or if I'm not mistaken, is in preview mode right now. Do check it out. So what really is CDK? Well, it's an open source, multi-language software development framework for modeling cloud infrastructure. And like I said, you're basically creating cloud infrastructure using your favorite programming language. The great thing about this is it's completely reusable. So say you enter a new company and you're like, hey, no one's actually done all of this. So you write a program in Python to, create a database and like a serverless function. You can actually give that same construct to someone else to create the same thing and reproduce it with all the defaults that you have actually built in. So I think that's pretty cool. The main three components of CDK are its core framework, which you see on the left. These are basically the resources that you can create. Now, a bunch of resources together creates an infrastructure stack, and a bunch of stacks together create an app that you will be building. There is also an extensive construct library. So as you would know, AWS has so many different services. 200 plus, and each of these most of these have their own construct libraries that either you can create or have already been created so that you can reuse. And lastly, of course, there is the AWS CDK CLI or command line interface, which is the interface you use to create all of this. Just to give you an example of how it makes your life easier, if I have to create a virtual private cloud with all those things that I told you about earlier, I'd have to write 270 lines of CloudFormation YAML code. Honestly, that's quite a bit. I have to specify NAT gateway and subnet and availability zone and CIDRs and all of that. With CloudFormation, take a wild guess as to how many lines of code you'll have to write. literally just one line of code. So I can just write something like vpc equals to ec2.vpc and just give it a name, and it actually creates a virtual private cloud for me with all of those settings enabled. Literally, I can just do it with one line of code. If, for instance, I say, hey, maybe there's something in the defaults that I actually want to change up, I can just add that as a parameter, and then with 2 lines of code, I've created the same thing. So that's 270 lines of YAML code that I typically don't have to write. So let's take a look at how the deployment workflow actually is. So this is it. You typically start in the CLI with something like an CDK init, and you should know what this does. It initializes a new project in CDK. You can also start with some sample apps, which, just it has a project navigation structure. It has the default, so it's just easier to do that. Once you've done that, you can do a pip install if there are any dependencies for your project. This uses the CDK CLI, of course. Once you've written your code to build cloud infrastructure, just 3 more steps to actually push that out to cloud. First one is CDK synth, which creates these templates and assets. Essentially, CDK synth is creating it into a CloudFormation code. You can do a CDK diff if you want to actually see what has changed. This is similar to a diff in, say, Git, where it actually says, okay, you've added these new pieces of infrastructure, or you've removed these pieces of infrastructure. And finally, you just do a deploy. And what this does is it just pushes all of the changes to the cloud. So say, for instance, you create a simple serverless function to store data in a database. When you do synth, it will create all of this. And then when you do a diff, it says, okay, create a database, created serverless function. And when you do deploy, it's actually pushed to your cloud provider. So you can actually see what's happening. There we go. Now, I've spoken a lot about how this works in theory, etc. But I know you want to see a demo to see if I'm actually telling the truth. Is it really that easy? Well, it is. So let me quickly show you a demo. The prerequisites for this are fairly simple. Of course, you need Python. You need the AWS CLI and an AWS account and user. If you're not customer of AWS right now, there is a very, very generous free tier. Granted, you have to enter a credit card, but you won't be charged. It's just for verification purpose. And the free tier limits are actually very extensive. So anything you want to do for testing or for just simple MVP or just to play around with it, please go ahead and do so. But of course, do check the billing page if you want clarity on what to do. Installing the AWS CDK toolkit is simple. Just do an npm install or a pip install. And just to make sure it's working, just do a CDK -- version in your CLI. So we're going to do something very simple and now create a simple virtual private cloud. The same example that I was talking about so far. I've pre-recorded this demo because, creating the CloudFormation takes maybe 4 to 5 minutes. So didn't want to waste your time looking at CloudFormation scripts running. So let's go ahead and get started. Now, hopefully you can see my screen. Yeah, there you go. So I'm just going to create a simple folder called CDK test and get into it. That's done. All right. So like I said earlier, we can start with a CDK init, and there are a bunch of sample apps that you can start with. Right. So I said CDK init and I gave sample apps. So it gives you something with the project structure that you can start with, and you can specify the language with which you want to get started with, in this case, Python. So that's what's happening right now. It's creating a virtual environment and all done. Now, because I'm using Mac, or if you're using Linux, you want to get into the virtual environment. So that's what I'm just doing right now. Just activating it so that now I can actually run this Python code. Okay, now that's done. Now this is the folder structure of what's created. As you can see, there is an app.py and there is also a requirements.txt, which has the dependencies of this project. So I'm going to do a pip install and first install the dependencies of this project. Yeah, I'm just looking at requirements.txt, installing a whole bunch of packages, and voila, it's done. So let me just open this. I'm opening it up in Visual Studio Code, and there you go. This is the sample app. Again, if you're not getting what's happening here, it's completely fine. You can just delete all of it because it's a sample app, but you can take a look at the project structure. So this is app.py, right? Let me just do that. App.py, where this is the starting point of your app when you're using CDK. So let's see here. And you can see something that says app.synth, and you see a region and a specification as well. You will also see some boilerplate code, which we're going to delete all of them because we're starting from scratch right now. So like I said, we're building a very simple virtual private cloud. If you're using Visual Studio Code, there's autocomplete, so that's another option. For each module that you want to install, or each construct that you want to install within your CDK app, you need to install it into your project first. This just makes sure that your project folder doesn't have all the AWS services installed. So if I have to create a virtual private cloud, I need the EC2 construct. Or if I have to create an S3 bucket, I need the S3 construct. I can do that very easily by just going and doing a pip install followed by aws-cdk.aws-ec2. So this is the construct for EC2 specifically. So now that I've installed that construct, I can actually import it into my app.py. Sorry, into my cdk test_stack.py. Literally just written one line of code that you see here. I've imported this module as EC2. So now I can reference EC2 in my project. Let's go. Like I said, creating a VPC is literally one line of code. So I'm just saying VPC equal to EC2.VPC. As you can see, there's autocomplete with Visual Studio Code as well. And you can literally give it any name. So I'm just calling it my VPC and done. Like I said, if there are other attributes you want to specify, you can do that too. Now, if I do a CDK diff, you will actually see the difference before and after I added that one line of code. There you go. Yeah, you can see a VPC is added. There's a subnet right there. There's a root table. There's a NAT gateway, a whole bunch of other things. So all of this has been added with that one line of code. And now when I do CDK synth, it actually converts that one line of code into a CloudFormation template, which you can push. As you can see, I've fast forwarded a little because this takes a couple of minutes, but that would have been your CloudFormation code that you would have had to write if it weren't for CDK and if it weren't for that one line of code. Isn't that pretty cool? I think it's pretty cool. Okay, now I'm just going to do something called a bootstrap here. I essentially want to take this CDK app that I've built and push it out to the cloud. It has to typically read from an S3 bucket. So that's how CDK works. Remember, I mentioned that before. You can do it two ways. You can push this to S3, or you can use the CDK bootstrap command, which actually bootstraps this line of code into a temporary S3 bucket. So it's creating a bootstrap environment. And now I can do a CDK deploy. So I just do a CDK deploy, and all of my resources that I mentioned in that app will be created. As you can see, it says creating CloudFormation chain set right here. This takes a minute or two because CloudFormation has to create all these resources. And yeah, it's creating, you can see it's creating the VPC, it's creating some metadata. If you go to your AWS console once it's done and just open up CloudFormation, you will actually see this in process. You can actually see each of the events that are being created. So as you can see, it says create in progress. You can toggle the view nested button and see all of the events that are being created with that one line of code. Again, pretty cool. So as you can see, it's done. If you want to see for yourself if it's actually done, you can open, yeah, it says create complete. So you can open VPC on AWS and you will see that a virtual private cloud has been created just for you with that one line of code. Yay. Yeah, there it is. I mean, some of this stuff still blows my mind that you can do all of this with just that one line of Python code. Now, of course, this was a very hello world type demo. Like I mentioned, this was a session for people who are new to this topic. But imagine entire applications in the infrastructure for each of these applications in lines of Python code. Now, that means you can run your CI/CD pipelines, you can share it with your teams, people. It's very reproducible. With creating applications, you do not have to reinvent the wheel. You can use something called CDK constructs. So let's take a look. Like I mentioned earlier, there is a library of constructs in AWS. For instance, for serverless, there's Lambda, API Gateway, DynamoDB. If you want containers, there's ECS, Fargate. All of these pieces of infrastructure can be represented in code using CDK. And the good news is there are already constructs readily available with best practices built in, so you don't have to create them from scratch. There are three types of construct levels. The base one, as called an L1 construct, is a CloudFormation resource essentially. So this is a CloudFormation resource that's automatically generated. Essentially, it's using straight up, it's a one-to-one mapping class, right, between CDK and an AWS resource. So that's that. The level above that is what is called an AWS construct. Now, these are slightly higher level service constructs like the one I just showed you in the demo. So if you want to create an S3 bucket, you say new S3 bucket and it's created. So there is a layer of abstraction above. These constructs are much simpler than a CloudFormation resource, and they require very little input, as you just saw. And finally, a layer 3 plus, which is purpose-built constructs. Now, like I said, these are very opinionated abstractions. So for instance, if I was building like a fairly complex load balancer, maybe I don't have to start from scratch, and maybe AWS tells you that these are the best practices that you want. So then you can use an L3 construct to say, okay, I'm just going to take these best practices and just create one. So let me give you an example. This is typically what an L1 construct looks like, where you're saying CFN bucket, so a CloudFormation bucket, you're giving the name, the bucket name, and all of that. And these are generating mappings from CDK to CloudFormation. So if you can see in this demo, the type of bucket is here, and you're mentioning that here as well. Also, you're calling the name my bucket, which is right here. So each of these things are one-to-one mappings of a CDK construct to a CloudFormation template. Typically though, we will use L2 constructs, which is what we just used. In this case, we said new EC2 VPC. It gives you all of these things ready to use. It's ready to use. All those IPs are split, default values, good to go. This is fairly commonly used, especially when you're starting out as well. So do check it out. L2 constructs can also be in this sort of case where you're building a slightly more complicated app. In this case, you're building an app, something that gets an object from S3 using Lambda and then stores it into DynamoDB. Now, instead of creating each of these by hand or using CloudFormation, you can actually write this code here to do all of it. So you can see there's a new table being created here. There's a new Lambda function being created here, and you're granting read and write properties. And of course, you're able to read from an S3 bucket right here. Again, just with like 10-15 lines of code, I was able to create a fairly intermediate level of complexity app using CDK and using an L2 construct. And finally, an L3 construct. Like I mentioned, this is purpose built. So in this example, we are actually building a VPC with all of this subnets, NAT gateways, route tables, all of that. This comes with a built-in load balancer so that if there is too much load, it's automatically balanced. And it comes with a Fargate service for serverless containerization, as well as an ECS task definition. Now you might think, if I have to build this on CloudFormation, it's going to take me 829 lines of YAML code. Quite tedious, can be prone to error, but with an existing L3 pattern, I'm actually able to create this using just 4 lines of code. So Amazon's launched few patterns, and the one you see here, you can just reference it from a particular registry and it creates all of it for you. Again, I think that is so cool, if I have to say so myself. So that is what an L3 construct really is. The great thing about CDK, in my opinion, is that it's a very vibrant ecosystem, and you can also create your own constructs or reuse constructs from people that are experts who have already created it. So there is CDK patterns, for example, that have pretty much every example or use case you can think of. So check it out. In fact, CDK Day is a yearly or maybe bi-yearly conference. It just happened, I think, a couple of weeks ago. Very vibrant community. So try and be a part of it as well. And I'm sure you'll learn a lot. I've spoken a lot about CDK, but just to reiterate, there are a lot of benefits to using CDK. One, I feel not too many people know about it, and they're very, very interested once I tell them about it. Especially the fact that you can use logic like if statements, for loops, conditionals when defining infrastructure. And I think that's this great new paradigm that I think will be very common in the near future. You can also use object-oriented techniques to model how your infrastructure should look. And of course, you can reuse your current infrastructure as library. Most importantly, you can reuse your existing code review workflow. Typically, that involves like a team lead, like some branching, some CI/CD pipelines, and you can incorporate your cloud infrastructure into this workflow as well. And of course, you can use it in the IDE that you are already using with code completion. Anyway, hope you learned something new today. If you are an intermediate user of CDK and you knew all of this stuff, then check out the next steps. There is a CDK workshop. There are a lot of samples you can check out. You can also contribute to the community. We'd love to hear, or we'd love to have contributions from you. So yeah, do check it out. I think it's fascinating, and I'd love to hear what you're building. If you have any questions, if you have any doubts, or you just want to share what you've built, hit me up on Twitter, LinkedIn, Twitch. I also run a YouTube show called the Emerging Tech Show, where I try to talk about emerging tech topics in a very non-serious manner. I just did season 1, so do check it out, and I'm recording season 2. Anyway, hope you learned something new today, and hope you're having fun at this conference. I'm having a great time so far. Enjoy the rest of the conference. Thanks for listening, and see you soon.